Hello my dear students, hope so doing really great. Welcome to the ESG physics classes. So students, in this class we are going to learn how to calculate electric field due to infinite wire, and after that we will see the derivation of electric field on the axis of uniformly charged ring. Okay, and that derivation is the very important. Okay students, so let's start the video. So you can see very well, first one we are going to see what? The cases of electric field by Gauss's law. In previous videos, I have calculated the 4 cases. Now it will continue with the 5th case. So the thing is, electric field due to an infinitely long straight uniformly charged wire here. Okay. So let's see one by one. Let's see here. Let charge is uniformly distributed on the infinite length straight wire having linear charge density lambda here. After that, EFI means electric field intensity. So electric field intensity at a distance small r from the wire can be calculated easily by taking cylindrical Gaussian surface as shown in diagram. So in next page we are just going to draw the diagram and we will see in a very easy mannered way how to calculate the electric field, very easy. So let's see here please. Here I have taken one wire, infinite wire is there. Now what is the meaning of the infinite wire? Actually the wire is not infinite. What is there? The observation point will be very close to the, compared to the length of the wire. Okay, and after that we'll draw here the, which one? Graph also, because question used to come for the graph also. Okay, so let's start here one by one. Now, so see please here I have taken one wire now, and here this charge is there. Now, most of the time by default we'll take here the positive charge. Even sometimes in the question they can give negative charge also. For that you have to be careful. Okay, now after that what I will take here, let's take for example I want to calculate electric field here at this point P. Okay, and this point is how much distance? R distance from the wire. Which distance? Perpendicular distance. Okay, now what I will do here, passing through this point here, I will imagine one Gaussian surface. Now symmetrical Gaussian surface should be there, as much symmetrical as possible. Okay, this is the symmetrical Gaussian surface is there. Okay, like this. Now we have taken the Gaussian surface and let's take the length. Length how much here? Let's take the length of this one is L. How much length is there? The length is L. So you know very well here, as the wire is infinite, that means what will happen that here electric field line will be away from the positive wire. In which direction? In a horizontal direction is there. Okay, let me draw here please. So at this point here, at this point here, this point I have taken one Gaussian surface I have taken. How much? For example, ds I have taken. Now, so here at this point, electric field in which direction? Electric field in this direction is there. Okay, and you know area vector also in a which direction? Area vector also in the same direction. Let's take here ds. So vector ds, and here vector E is there. Okay, this is the just way. Even if you take here also, here also electric field in which direction? This direction, and area vector also in which direction? This direction is there. Okay, very easy. Now after that you know very well, here how many kinds of surfaces are there? 2 surfaces. One is the curved surface, is it? And one is the which surface? Flat surface is there. This is the flat surface. This surface is the flat. This surface is the flat. Okay, if you see from the upper view, that flat surface will look like a circle. Okay, so what we are going to do here, we are just going to use the Gauss law. So from the Gauss's law, what we can tell from the Gauss's law, we can tell total flux is equal to charge enclosed by epsilon naught. Okay, now after this here, which kind of surfaces are there? One is the curved surface and one is the flat surface, and here charge enclosed by epsilon naught. Now we are going to decode all these things one by one, is it? So now if we talk about here, which surface? Curved surface. So you know very well, as I have shown you, this side also, angle between electric field and area vector how much? 0 degree, and you know the flex formula, EA cos theta, cos 0 is 1, that means we have to just multiply electric field and the area. Okay, so electric field how much here? At all the points of curved surface, electric field will be constant how much here? E, and the area of the curved surface, the total area of the curved surface is how much here? Radius is r here, length is L, so area of the curved surface will be how much here? 2 pi RL. Is it? The total area. Plus flat surface how much here? Electric field lines will be parallel to the flat surface, they will not cut the curved surface, that means here how much here? 0. After that, can you guess what is the enclosed charge here? You know very well, enclosed charge is given by lambda, means linear charge density, that means charge per unit length into the length in which this we have drawn the Gaussian surface. That means we can write here lambda into L. Q enclosed is how much here? Lambda into L by epsilon naught. Now can you see very well both the sides, anything can be cancelled out here. This L cancel. That means we can write here electric field is given by lambda by 2 pi epsilon naught r. Okay. After that, now this is okay. This one we have got here. Even if you multiply both the sides means here in the numerator and in denominator into 2 by 2 for example, then you know what will happen that here down it will become here 1 by 4 pi epsilon naught into 2 lambda by r. So we can remember like this also 2k lambda by r also. And what is the value of the k? 1 by 4 pi epsilon naught here, epsilon naught r. Okay. Now if we draw here the graph here, you can see very well here from here E is inversely proportional to r. That means which kind of graph? The graph will be rectangular hyperbola here. So see please here, this is O, this side for example x, this side minus x. So the graph will go like this here, like this you can do here. Okay, and both the sides what will happen that here? E is inversely proportional to r. Okay, for example, if in case you want to know electric field in a vector form for example, anytime needed. So if I talk about at point P, so at point P if I write here, the electric field will be how much here in a vector form? 2k lambda by r into what you write here? I cap, and here I will put here the vector sign here. Similarly, if I take this point here, let's take this point, I have taken P dash here. Then can you tell electric field at point P dash how much here? Same 2k lambda by r, but electric field in which direction? Away. That means we have to write here minus I cap and then vector sign, because basics should be very clear. That's why I'm writing in a vector form also. Okay. Now students, we will see electric field intensity due to multiple thin wires. Okay, very very important for the exam. So first one we are going to see when both the wires are positive. Here plus lambda, here also plus lambda is there, and here in middle I have taken point A. Okay, so this distance how much here? R by 2. This distance also how much here? R by 2. Okay, the wire. What total wire is the straight only, okay, but the point A I have taken in the middle. So what will happen at here? Let me draw here the directions of the electric field due to first wire. Let's take the first wire, electric field in this direction. I can write here EA1. Similarly, due to second wire, electric field in which direction? This direction. Okay, so anyhow, you know very well, both these electric field lines will cancel out here. Okay, but anyhow, for you, I will just write here electric field at point A is given by what to write? EA1 plus EA2. Okay, so what this will become, students? In this situation, we can write here EA1 how much here, as I told you, 2k lambda by how much distance? R by 2. And what to write? I cap plus 2k lambda by R by 2. And what to write here? Minus I cap, because opposite direction. So what will happen? Anyhow, both will cancel out, and here electric field how much here? 0. Okay. After that, students, if we talk about here the second case here, here I have taken the second case. Now what is here? This is minus lambda. This is also minus lambda, and now I have taken point B here. Is it? So here R by 2, and this also I have taken R by 2. Now can you guess very well what will happen there? Very easy. Now again this 1 is there, but negative. So what will happen now? Electric field in this direction. I can write here EB1, and due to this one, due to second one, electric field in which direction? This direction. Here also what will happen? Both this field will cancel out. Okay, so if I write here EB is equal to EB1 plus EB2. Now EB1 how much here? EB1 in a vector form 2k lambda R by 2 minus I cap, direction reverse, plus 2k lambda by R by 2. That's it how much here? I cap. Now again what will happen at here? It will cancel out here. Okay, so here again what will come here? It will come here the 0. Is it? Now after that you can see when both are plus lambda, both are minus lambda, electric field at the center point how much here? 0. But if you see the second situation here, not second, third situation actually. Now situation is actually different situation. Now so we can tell now this is plus lambda, and now this is minus lambda here, and now I have taken point C. Now can you guess what will happen, students? Yes, so see here please here. This is R by 2, and this is also R by 2. Let's take first. So electric field in which direction? In this direction, EC1 away, and this is minus. So again electric field in which direction? Now towards at point C in which direction? Towards. So we can write here the EC2 is there, EC2. So now electric field at point C is given by, students, we can tell EC1 plus EC2. Okay, now this is EC1. EC1. Now EC1 how much? Just guess please here. Very easy. 2k lambda by r by 2, and here I cap direction only, plus 2k lambda by r by 2. Don't put minus lambda and all that. Here lambda only magnitude and then proper direction I cap. So what will happen right here? This will become 4k lambda by r. This will become 4k lambda by r. Then what this will become here? This will become here 8k lambda by r I cap.